All right, in this video, we're going to look at multiplying and dividing rational expressions, and the concept is the same as when you multiply or divide fractions. When you multiply, you want to cancel any common factors before multiplying, and then you just multiply across. When you're dividing, you have to multiply by the reciprocal. So the first one we're going to look at is, again, one that has monomials. In this case, before you multiply, I would cancel the numerical factors first. And so when I look diagonally here, I know 3 goes into itself once, goes into 9 3 times. 6 and 8 have a common factor of 2, so 2 goes into 6 3 times. 2 goes into -8 -4 times. And rather than cancel all these m's and n's over here in the multiplication phase, this is the only example where you would multiply across the variable expressions and then cancel. In all other cases, when you don't have monomials, you're going to factor and cancel. So let's multiply. Actually, we got one more thing we can cancel here. The 3's will cancel. Now, to multiply across the numerator, I get -4. And then I have m squared times m. That's going to be m cubed. And then n to the 4th times n cubed is going to be n to the 7th. In the denominator, I just have 1. 1 times 1 would be my numerical coefficient, so I won't put that in. M to the 4th times m to the 5th is m to the 9th because I'm adding those exponents. N cubed times n squared is n to the 5th. Now you can use the rules for the quotient rule for fractions when you're dealing with exponents. And so the m's are going to end up in the denominator. You would subtract 3. The n's are going to end up in the numerator, where you would subtract 5. And so my final answer here, in the numerator I'm left with a -4 n squared, and in the denominator I'm left with m to the 6th. Now in part B here we have polynomials. We don't have monomials. We have more than one term. So we'll factor using all the different methods that we've learned. Now I'm not going to go through the steps of factoring all of these. You can pause and try to factor them. I'm going to just write down this expression in factored form first, and then we'll talk about how we go about canceling. So here I have factored all the polynomials. One of them was a difference of two squares, 8 plus x, 8 minus x, and I'll go ahead and cancel any common factors. Now when you're multiplying, you can cancel up and down, you can cancel diagonally, but you cannot cancel across. So I have an x plus 8 and an 8 plus x. Now those are not opposites, those are actually the exact same factor. I have an x plus 7 and an x plus 7. Now when I replace those, I'm just really replacing them with 1's. Right? I have an x minus 2 and an x minus 2. And here I have that scenario again, x minus 8 and 8 minus x. Those are opposites of each other. And so you're left with a -1 there. So when you multiply across, here, everything cancels. Now, if everything cancels and you didn't have a negative, the answer would be 1. In this case, everything cancels, but you had these opposites here. So the answer to this one is just -1. All right, now let's go down here and do one division problem. And on this one, I will go through the factoring because we've got a little tricky problem here. When we've got the leading coefficient is negative, we want to rearrange this. We want to write this in descending order before we factor it. So two things I'm going to do. I'm going to rewrite that numerator in descending order to make it easier to factor, and that's in descending order of exponents. The denominator I'm going to leave the way it is. And now, anytime you divide by a fraction, you multiply by the reciprocal. So the reciprocal of 2x minus 8 is just 1 over 2x minus 8. Now that it's a multiplication problem, I'm going to go ahead and factor. And I'm going to factor the numerator off to the side. because this requires a little bit of work here. So when I factor, I'm going to factor out a negative so that it'll be easier to factor the remaining polynomial. And I'm not just going to take out a negative 1, I can take out a negative 2. Then I'm left with 2x squared minus 5x minus 12. And now I'll factor this using the bow tie method. So 2 and 1 and 12 and 1, or 2 and 1 and 4 and 3. And I actually have what I need already, so I won't even bother doing the 2 and 1 and the 2 and the 6. Here, if I multiply, let's see, do I have what I need? Yep. I'm looking for a difference, so this is going to be 8 and this is going to be 3. The difference has to equal negative 5, so I circle diagonally. So I'm going to get negative 2. And then the 2x has to go with the 3. The x has to go with the 4. The larger product has to match the middle sign. So the number next to it has to match the middle sign. So this is going to be minus and a plus. The rest I'm going to factor, I'm just going to put the factored form in. Right, now that I have all polynomials factored, I want to cancel any common factors that I see. All right, now you can, remember, every time we cancel, we're replacing those with 1. You don't have to do it physically. You don't have to write the 1 down if you don't want to. And then the x minus 4s are going to cancel. And I look to see if there's anything else. I can actually cancel this too with this one, so I'm going to get negative 1. And so my final answer, I'm just going to multiply across what's left. In the numerator, I just have a negative 1. And in the denominator, I have an x plus 5. All right, so this should be enough examples to kind of help you get through the homework. Make sure you use the My Math Lab help buttons and email me if you have any issues at all.